One of the leading causes of low back injuries in the workplace is overexertion. So this is repetitive wear and tear for people who are in jobs where they do a lot of lifting or bending. And so part of what we were trying to accomplish was figuring out a way that was practical, that was deployable, that was scalable, where we could help to relieve some of that strain off the backs of workers.
So I started out on this journey as a graduate student at Vanderbilt University in the Center for Rehabilitation Engineering and Assistive Technology. And what I found was that while we were doing groundbreaking research into how to assist people with disabilities and to improve human performance, a lot of those technologies just went to the dustbin and they never actually got anywhere meaningful as far as impacting society.
So I got interested in reducing back pain about 4 years ago. I started developing some back pain of my own, and I believe it's because of my kids, from all the lifting and bending and crouching that's involved in parenting.
So over 90% of people get back pain in their lifetime, and one of the major contributing factors is repetitive motion and high loads on the back due to the amount of manual labor that happens in this country to keep the economy going.
So in developing the Apex exosuit, we were really focused on workers and worker safety. Many of us have experienced back pain, and it affects every facet of your life. It doesn't just affect you at work, it affects you after work. And so we were really focused on figuring out how do we deliver something to these individuals that would make their lives easier. And what we figured out is that by embedding springs, elastic bands in their clothes, we could actually redirect some of the load to go through the elastic bands rather than through the low back muscles.
We focused on trying to understand how much effort do your back muscles have to put out in order to lift an object. And you can measure that electrically, just like someone will get an electrocardiogram. We can use that same technology to measure how hard your muscles are pulling in any action that you might take. And so we use those types of sensors and then measure people repeatedly lifting objects or leaning over several scientific studies to understand how their body is affected by using the suit.
We're able to show that this reduces the strain on the back by about 15 to 30% during bending and lifting, and that this reduces the fatigue rate on your low back muscles by about 40%.
So it's enhancing human performance, but the flip side of that is that allows us to actually make people more safe. So they can do the same amount of work, but at less risk to themselves. So in starting HeroWear, it was my dream and hope that we could take some of the very cool technologies we've been developing in the lab and turn them into something that actually affected people's lives.
So the Bayh-Dole Act was one of the critical pieces that allowed us to commercialize this technology. It allowed us to take the innovations and the inventions that we came up with at Vanderbilt University and to exclusively license them so that HeroWear could go all in on this product, on this vision to reimagine and reinvent the future of physical work. And we think this is going to have a tremendous impact on people across the globe, not just because it is an assistive technology, but because it's practical, because it's something that can actually be worn day in and day out by people who are in different occupations, whether you're someone working in a warehouse, on a construction site, and in the future for healthcare professionals as well, who do a lot of bending and lifting. We're really excited about how this technology can help keep people safe and healthy far into the future.